Okay, so I'm going to be about Android and Bitmaps. The original title, well, as I've guessed out, was to do with list using Bitmaps, but I decided it was going to be a bit much because I didn't want to actually have that much to talk about. And luckily, it turns out that I think Nick's going to do a much more in-depth one around it anyway, and more from an experienced user's point of view. So my talk's going to be basically about my experience. Like, I've been doing Java for a pretty long time, but I'm pretty much a newcomer to Android. Like, I've really only worked on my first serious app, as it were, in the last few months. So this is going to be about my experience in writing my first significant Android app, rather than just like little testing prototypes. The app that I made is called Sketch Notes, and it's all about Bitmaps pretty much, because it's meant for tablet devices, but also can be used on your phone to let you do basically rough sketches and be able to filter them and like sort them. It's only got some of the features I want in it, but I think it'll be a good starting point because it will cover a lot of different APIs that I've used to get a rough idea of Android. Now, Bitmaps and Android, as I found out, not quickly, I got a fair way into it before I realised that they were a bit special. They make it like interesting because, I don't know how many of you know, probably most of you do, because I'm a newcomer and this could be a bit by surprise. Up until Honeycomb, it turns out bitmaps aren't actually regular, well, they're regular Java objects, but the actual bitmap data isn't inside the Java object, it's actually allocated natively. Apparently this is different than Honeycomb, though I don't have a Honeycomb device yet or a reasonably working emulator to try it out, but that's what the docs say. So the problem is that the data is being allocated natively in some, I guess, C++ code, but it still counts towards the heap quota that your application gets because it's still being allocated in the process that your app's running in the Delta VM. Now that quota, for those of you who haven't seen that little tick box that you get, or little box that you get when your emulator fires up, is not particularly high. So in 2.1 it was up to 2.1 it was 16 meg, 2.2, 24, and 2.3 apparently has been bumped up to 32 meg, and I take it from what I've read online, it's mainly to do with the resolution devices getting higher, and then realising that one of the main uses for memory is for people to put bitmaps into, and high resolution screens mean bigger bitmaps. Now, when I was testing my app, I was mainly testing it on hardware-wise on one of the first generation tablets, the Optus ZT Mini 9 tablet, which is only 800 by 480 resolution, so by the time you have enough space to say, for me to do my drawing, it's roughly 732, I think, by 480 is what the resolution of the bitmaps that I work with on in my app. So that's roughly 1.4 meg out of 60 meg that the whole app gets in terms of heap space. So yeah, you've got to be a bit careful when you start working with a reasonable number of bitmaps. Now, the problem is that there's a wonderful allocation tracker tool that comes with the SDK, and there's nice GUI for it in Eclipse, but it's not really much use because this memory is being natively allocated, so it's not tracked by the Delta VM, and hence you're not going to see it in the tracker tool. So what that meant was that you pretty quickly, once you start testing out with any reasonable amount of data, not just 1 or 2 bitmaps, which I did for the first 2 weeks, and then actually put in like, a dozen, and all of a sudden you get the dreaded out of memory. And yet that's the helpful, or that's the one out of the huge stack trace that you get line that basically tells you it's the bitmap that did the dirty on you and caused you to run out of heap space. So like any good, reasonably lazy programmer, the first thing, and especially if you're new to Android, I went and had a look on Stack Overflow. Yes, I'm not the only one who's run into this problem. I'm just basically a bit late to the game. So 3,800 hits just copying and pasting that into stack flow. So I got a bit, I guess, obsessive about this problem and spent a bit more time than I probably should have investigated it. So first of all, after a bit of Googling, I found out, like, I don't know if you can all see it in blue, there's a helpful class called Debug, and it's got a handy static method called get native heap allocated size. So that's really the most helpful thing I found in terms of trying to find essentially my memory leaks, but still it was really useful because it was pretty much I could see how much space all that natively allocated memory was taking up in my app. And yeah, it wasn't a surprise to basically the first time I plugged a few of those debugs into my code, I just saw the memory usage go up, bang, out of memory, all close. There's a few other interesting methods on debug that I found. One that I thought was handy, I haven't actually made use of it myself, but I'm planning to write a little bit of test harness to use it, is that you can actually call a method to dump the href file rather than having to manually click to do that either in the Eclipse or command line if you're using the SDK command line. So I thought about maybe it'd be a good idea to actually understand why this is happening rather than just sort of running around and trying different things that I found on Stack Overflow, mailing lists, various other places. So I started researching a bit more. There's a quite long bug, 488 on ASOP bug tracker, which, if you have time to read it, it makes for really interesting reading. It's actually not specifically about just the memory leak to do with Bitmap per se, but about using different types of the I/O classes to read about maps. And I think there was actually, at some point, I don't think it's still there in 2.3 at least, a bug in one of the factory methods that you can use to read in the maps, which is what originated the bug. But anyway, it was full of handy information. And basically what I found out was that the problem occurs because in order to free up the natively allocated bitmap memory that the bitmaps allocated, the garbage collection does work. So if the garbage collector runs, what happens is if it spots that your bitmap object can be garbage collected, it will of course run its finalizer. And apparently bitmap's finalizers then have a call via a fairly long chain into the native function, obviously C++, that actually frees the memory allocated. So as long as the garbage collector runs, cleans up your bitmap, it should run the finalizer, clean up the memory, and all good. The problem is that does it run when you need it to run? Like if you're allocating a whole bunch of bitmaps, is the garbage collector going to run quickly enough? Because remember, it's not running at a specific point in time, it's running at some point in time. So if you're busily allocating, so for instance in my list view, I'm busily allocating a whole bunch of bitmaps, you quickly do that, quickly enough, and the GC doesn't have time to actually free all that memory up, well, without helping you, which I'll get to in a second, so you use up your heap and you run out of memory. So some of the advice in that bug report was, run system GC a lot. Now, I'm pretty sure I remember this from when I was doing, I think it was Java 1.1 for some really funny outputs that I happened to be working on just when I was learning Java. I'm pretty sure I saw that same advice somewhere on a mailing list or something somewhere. No, I don't think it's gotten any better in all these years, so I'm pretty sure no is the right answer to doing that. So I dug a bit further. I found a fantastic blog by one of the people who commented on that bug, digging into probably more info than you really wanted to know about the cause of this and all the details surrounding it. He actually went through, he grabbed the Android source code, went through looking at where the Bitmap's Java methods called into native code, and then he looked at native code and looked at what native code did, and basically found what I've just run through is that eventually what happens is if the finalizer runs, the native memory gets freed up. If it doesn't, then no go, you run out of memory. However, the thing is, you can actually explicitly have that code path followed by calling the recycle method that happens to be on every bitmap object. And what that does is instead of calling systemgc and you're basically asking, at some point please run garbage collector. I'd like you to do it now, but I know you're going to do it at some time in the future. Apparently, recycle does it synchronously. So when that comes back, you know that memory, that natively allocated memory, has been freed up. So that's what you should be calling when you've got allocated a whole bunch of bitmaps, or you're allocating a whole bunch of bitmaps really quickly, and you want to say in a tight loop, and you want to say, yep, I finished with this bitmap, I'm on to the next one, get rid of it, free the memory from it, let's keep things moving along without simply just filling up your whole heap and running out of memory. Now, apart from tracking that down and hopefully helping at least one of you who hasn't run into this and will in the future know that you have to explicitly call the recycle method. I know it kind of goes against the grain because, you know, the garbage collector is supposed to do its work. Like, you know, it doesn't stop memory leaks, but most of the time you don't actually explicitly have to worry about freeing every little piece of memory. You just got to make sure you don't leak references to your objects, and then the garbage collector can do its job. In this case, you actually have to do more what you do in C and C++, and actually say, right, at this point in time, I finished with this bit of memory, free it, because I need it for something else.